This is chapter 6, problem number 26. The lucky number for this problem is 2. We are talking about gravitational potential energy. So what is it? If you have an object, and if you want to bring this object, and by the way, when this object is sitting on the ground, it's going to feel two different forces. So let's draw a free body diagram. Gravity will bring it down with the force mg. And since it's not moving, so there's no net force acting on it, so there must be another force. It's called a normal force acting on it with the same amount of magnitude. Now, if I try to move this object to the height, let's say, of h, so how much energy do I need it? So before we know that mechanical energy work, that is equal to force times distance. And if it moves at a constant velocity, that means no net force is acting on it. So you have to put mg, that would be a force, and then that's the force mg. And if you move with the distance of h, so the d is equal to h now. Okay, so this work is equal to mgh. That means the energy that need to bring this object with the mass m that goes against the gravity goes up to the height h. The energy is equal to m times g times h, or delta h, if you decide to have the final height minus the initial height. So this is what we are going to give a new definition. Instead of mechanical work, we are going to give it a new definition, and it's called gravitational potential energy. Okay? When people say potential energy, sometimes they refer to as gravitational potential energy. So I'm going to just call it potential energy for now. Potential energy is equal to mgh. Mechanical energy is equal to force times distance. So what is the difference? If you move something horizontally, let's say you have a force moving to d distance, yes, you are acting work on it. There's friction. However, the potential energy due to gravity or gravitational potential energy from here to here is 0. Why? Because there's no h. You're not against the gravity. You just move horizontally. So in this case, mg times delta h will be equal to 0. Okay, let's go back to our question. By how much does the gravitational potential energy of a 54 kilogram pole, okay, want to change if a center of mass weighs 4 meters? Okay, so someone is trying to jump. Okay, so what is the gravitational energy? It's equal to mgh. M is 54. M is equal to 54. G is 9.8, as we know, and h is 4 meters. If you multiply all this up, is the potential energy, and it's equal to 54 times 9.8 times 4. That is equal to 2117. And if we put all the units in standard unit, energy should have the unit of joule.